Welcome to a video on Maxava Capture Point Restore, the event-based archiving solution for your IBM i. As provider of the class-leading high availability solution for IBM i, Maxava is driven by the need to protect our customers from disasters of many types. As you may know, the Maxava HA solution replicates data and object changes in real time to a backup server, ready for a system failover if necessary. Real-time replication works on the assumption that what is done on the production server is correct and should be cloned to the backup server. Most of the time that is exactly what our customers want, but sometimes it isn't. Maxava CPR is for other disasters caused by malicious intent or just simple carelessness. For example, where a critical file or program is deleted in error. CPR simply identifies that action and before the request is executed, stores a copy in a vault location for future use. CPR identifies a capture point moment and performs the archive. That can either be at the time of a deletion request or perhaps at the right time in your application processes. The archives are then available for restore purposes if the need arises. Please note that when integrated with the Maxava HA solution, extra flexibility and functionality is available. So when combined with Maxava HA and Maxava MI8 Monitor, CPR is part of a total software solution for reducing the impact of disasters. The screens which follow will be a combination of views from the CPR graphical interface itself, as we see here, and some actions performed on IBM green screen sessions. This home page within CPR shows us a general status summary. It is active, no requests are pending, we have some copies held in archive storage, and other housekeeping information. During the demo, we will be using one system acting as a production server called USQPRD that has already been set up to replicate to the backup server called USQTGT. So Maxava HA is running in the background to perform replication. This IBM emulation screen is intentionally colored blue, so we will remember that this is the production server. Here we see the contents of a customer file in the library CPR demo. There are 5 records which have been added and updated over time. The next IBM emulation session is the more traditional black and green screen. This is the backup server. Looking at the same customer file in the same library, we see exactly the same data as on the production. This is because the Maxava HA replication solution is performing its tasks correctly. As we add and change records on production, they will replicate to the file on the backup server we see here. To make this demo interesting, we will now perform some tasks as a developer who has been given access to some parts of the applications on the production server. As the actions the developer will perform are also on the production server, our emulation session is a different shade of blue. Here we see that the developer has a version of the customer file in their personal library called mylib. They may be using this to test some processes or promote some new programs live, etc. The contents of the customer file are obviously different, with just 3 records. The developer has now finished their work and will remove their testing files as they are no longer needed in mylib. They issue the delete file command. Unfortunately, they chose to perform an unqualified delete. They did not specify which library to remove it from. This means that the operating system will look at the developer's job and find the first version of the customer file in the library list. At this point, the developer panics because they did not remember they had also used the production library earlier today. When they check the completion message, as the cursor is highlighted, they see that the wrong customer file has been deleted from the production server. Checking on the backup server, we can see that the delete of the customer file has been performed here too. No matter how it happened, unintentionally or intentionally, the file has gone with all of its precious data. Normally this will be a major problem. If there have been numerous updates into that file since last night's tape backup, the company is looking at having to regenerate those changes somehow, a difficult task at the best of times. But what if those changes were driven by online commerce or data received from external servers? This is where CPR comes to the rescue. We had previously defined that some of the files on the production server were so critical that we authorized some capture points on the backup server. Looking at the CPR GUI, we have accessed the registry. This is where each capture point is logged. Interrogating the registry, the record on the top of the screen shows that an archive was performed of the customer file. And the timing of that was just before the delete was actioned. The right-hand window confirms the detail of the archive. We breathe a sigh of relief, as we now know that we have a way out of the problem. We make the decision to restore this version of the customer file and request that to be performed. Note that CPR insists that the object be restored into a different library on the backup server, as we know that some manipulation may be necessary. Looking at the backup server, we see that all our data is back, though in a different restore library, as highlighted by the red cursor. We can now start to fix the problem. The developer example we've used so far is not the only thing we can protect from. Here we see another scenario where a security person wants to check the authorities defined against some programs. Unfortunately, because they were working so fast, they did not notice that they had fat-fingered one of the options and will actually be deleting program 3. Here are 2 more ways to cause panic in the organization: clearing a member or removing a member. This is not an exhaustive list, but hopefully you can see the power of CPR in dealing with the imperfect humans that we are. In the background, CPR holds definitions of where to store the archives. Here we can see that there are a couple of storage locations, and the right-hand window shows that it is using an IFS file location and has limited the space available for storage. A threshold parameter will be used to alert if archives will soon need to be purged due to space issues. The CPR coverage rules hold details of the objects we have defined capture points against. Coverage rules can be defined specifically or generically to make the system as flexible as possible. Each rule can specify a different storage location, and parameters are available to allow up to X number archive generations to be held, with automatic purging. For security and management verification, CPR actions are logged for later interrogation, as we see here. In addition to the internal logging of CPR, some of the more critical events can be pushed to the Maxava Cloud Monitor MI8. Here we see one of the MI8 views that can be accessed via a browser session on a PC, tablet, or phone. The red icons notify us that an archive took place for the customer file on the backup server, and that we have reached a storage threshold, so some manual intervention may be required. MI8 is a powerful, flexible, and modern tool that monitors not only CPR, but the health of disaster recovery environments, along with system attributes and application performance. If you would like to know more about the full MI8 monitor functionality, please let us know. As was mentioned before, capture points are not only triggered by deletion events. Some customers have chosen to incorporate CPR into their existing processes by using the command shown here as an API within their in-house processes. So if you would like to take an archive copy of some files and objects just before your daily batch run, or after the month-end payroll reports, or at 6 AM, noon, 6 PM, or midnight, you can do just that. CPR solves a critical problem in a non-complicated way. The impact of losing the current version of files holding prices, customers, orders, recipes, product specifications, etc. can be very, very high. There is a lot of value held in these objects, and their loss will be a disaster, though on a more focused scale than a system disaster. There are other elements of CPR that we have not covered here, such as the ability to take a file from a scheduled or event-driven archive and roll back or forward in time until you get the version of the data you want. These are more successfully demonstrated in a one-on-one session. What we have tried to do with CPR is to provide a focused solution to a known issue in as straightforward a way as possible. If you would like to learn more about any of the topics that were covered in this video, please reach out to your Maxava representative or partner. Thank you for attending this session and taking time to learn more about CPR, Capture Point Restore.